Okay, so we're going to look at this problem here. The diameter of each wheel of a bicycle is 26 inches. If you're traveling at a speed of 35 miles per hour, how many revolutions per minute are the wheels turning? So what we're going to do here is we're going to look at a couple of our formulas here. I know that this here is my linear speed formula, and this here is angular. And we can see that the angular is going to be in radians, and the linear is going to be in either miles or feet or inches. And then this formula here talks about how my linear speed relates to my angular speed. So if I take my linear speed, it will be equal to my radius times my angular speed. I also know that one revolution, if I'm going to convert revolutions into radians, that one revolution is equal to 2 pi radians. And all that information is going to be needed to solve this problem. So to start this off, I'm going to take this formula here, my linear speed equaling my radius times my angular speed, and I'm going to rewrite it because I'm trying to find the angular speed so that I can convert it to revolutions per minute. So this is going to say my angular speed is going to equal my linear speed divided by my radius. So all I did was rewrote this formula here so that it would be set up the way that I need it. So that's what I'm going to start with. So my angular speed is going to be equal to, my linear speed, they tell me, is 35 miles per hour. I'm going to divide that by my diameter, my radius. My diameter is 26 inches, so to find my radius, I have to cut that in half. So 13 inches. And then what I'm going to do is I'm going to start doing some converting because I need this to be in terms of revolutions per minute. And we're talking about inches on our bicycle. So I'm going to convert this from miles to inches. So in order to do that, I know that I'm going to multiply this. And we've got 12 inches in 1 foot, and then I have 5,280 feet in 1 mile. Okay, so when I multiply all of that together, I take the 35 times the 12 times the 5,280 and I divide it by 13. What I end up with is 170,584.62, and this is radians per hour. So I can see here that my miles crossed off, my inches crossed off, my feet crossed off, and what I'm left with, since we're talking about angular speed, I know it's radians, and it's per hour. Okay, so now I'm going to take that number, and I'm going to convert it now so that it's in terms of minutes, because we're asking for revolutions per minute. That's what the problem asks for, is revolutions per minute, and I have hours. So 170,584.62, and this is radians per hour. I'm going to multiply that times, well, let's see, we know that 1 hour has 60 minutes. And then I'm going to convert it here so that instead of being in radians, it's going to be in revolutions. So because we need revolutions per minute. So I know that 1 revolution is going to be the same as 2 pi radians. Now, when I multiply this together, 170,584.62 times 1 hour times 1 revolution, and divide it by 60 times 2 pi, I end up with 452.49, and we wanted revolutions per minute, And if we look back here, we can cancel out, okay, well, my hour, whoops. My hour crosses off here, and I'm left with minutes. My revolution is left here. My radians cancel out here and here. So I'm left with revolutions per minute. So there's your answer.